Okay, is it go time? Oh, fair enough. Okay, everyone. Uh, Thank you for coming to this talk. I'm Manuel Gomes, and I'm going to be talking about Drupal at scale. So, me, I'm I've been a geek for a long time. Interesting tidbit: I have never written a single line of Drupal code. So, what the hell am I doing here, right? And the answer is that recently I joined dropsolid. They are a digital experience company, and Drupal is very much at the core of their offering. I've joined more in the platform kind of role than um, a technical Drupal thing, but it's been interesting. So this whole digital experience platform involves content management, involves marketing automation, customer data, personalization, and this is what our clients want, and we deliver it through Drupal, Matic, you know me, and whatever else uh, custom stuff our clients may want. It's all open source. We insist on data sovereignty. In fact, we put an unholy amount of effort into offboarding, which is kind of, wait, you want to make it easy for people to leave? Yes, actually, we do. There's security by default. Just got the ISO 27001 certification. GDPR is a first-class citizen, and it is community native. What do I mean by community native? Well, hell, I'm here, and here's another guy. So, yeah. Currently, this changes a lot, but we have 500 clients, 550 production projects. Under the hood, that means 1,400 environments on 200 servers. You don't want to manage that manually, trust me. So, so we built a platform, right? It's pretty unavoidable. And today we're going to talk about language, most of all. Not PHP or Python or whatever. The language that we use to tell the customer narrative and the language we use to think about our platform. And I think that language is incredibly powerful, and that if you choose the right language, you are halfway there. So, let's talk about language. We have nouns, we have project, server, user, environment. We have tenancy, we have organization, we have backup, we have log, we have whatever, and verbs. Clone, delete, create, update, rollback, etc. Obviously, these are very high level, and they should be. So we're going to talk about truth as well. And truth the Drupal way, we built it with custom entities. And we did ACLs, and we're keeping state somewhere. And we put that into action. Now, we're not going to go into a huge level of detail here, but we built a platform on Drupal. Because, once you have a hammer, everything tends to look like a nail. So there you go. We use Drupal. There is a REST API. There's a bunch of queue jobs, transition queues, etc. The state machines, RabbitMQ, task workers, response workers. These are we're going to talk about them again. And Ansible with playbooks, roles, and inventory. And then, you know, there. Okay, let's try this again. Yeah, that's okay. Maybe turn this off. Yeah, cool. Which then talk to our infrastructure. Seems to make sense until Drupal is not an application platform. It's a kick-ass CMS. Make no mistake, but it was not meant to be an application platform. So when you make a revision of something, it bites you. If you want to store blobs, you're buggered. So our REST APIs caught on fire, and the state machines caught on fire. We couldn't keep up with the pace of the platform. Ouch. So we defended with queues. And Celery on top of RabbitMQ, that worked well. We can throttle, scale, retry. We have good queuing semantics with this. We achieve at least once delivery, which means that we're not dropping our platform actions on an empty bag. We always actually action them. Okay. That was good. And then everything was Ansible in the backend. Oh dear. Make no mistake, Ansible is great. It's awesome. But sometimes we use Ansible just right. Hey, hammer, nail, awesomeness. Let's do this. Creating cloud instances, etc., configuring them, getting the right things in place. It's got a broad ecosystem. It's flexible, it's extensible, pretty good. And then we did some more Ansible. We can rewrite configuration files. We can start services, stop services, rewrite them, point things elsewhere, etc. Ansible doesn't really speak concurrency natively. Rollback, you have it if you implement it, but it's not a native Ansible thing. Atomic writes, again, if you write them, they're there, but they're not a first order concern. And sometimes, look, Ansible is not a programming language. It's not an application framework. You're clearly using the hammer for things that it was not designed to do, and things that do not react well to hammers. You can actually write applications that then Ansible runs, but suddenly the separation of concerns is not all it could be. It gets hard. It requires discipline. It requires good software engineering. It fights you. You can succeed, but it's a lot of orchestration. State machines, finite state machines. Everyone heard of them in OMSI or wherever. They're good. They keep you out of too much trouble. A bit like we used queues in the first place. We use state machines to have a deterministic success or fail, to know where stuff went wrong, what it did, to resume, to revert, because we know what has been done so far, so we can walk it back. It's a start. So now we have vocabulary, we have our nouns, we have our verbs, and we have a grammar. This grammar allows us to write sentences, and these sentences articulate the value that we are actually delivering to our customers. They also have some characteristics, or ideally, they have some characteristics. They should be readable. You should look at them and immediately know, this is what we're doing. They should be auditable. Once you execute them, you have to be able to track everything that they did. They should be unambiguous because, life has enough ambiguity already. Thank you very much. And idempotent. If you say the same thing twice, it should be exactly the same thing as saying it once or saying it 50 times. Because this way, remember, at least once delivery, that means that you can double, triple delivery sometimes. And that has to be okay. And, there's heaps of other stuff that we have to do differently. Because as things scale up, you have to defend your own sanity. And since I'm new to the ecosystem, to dropsolid, I'm going to talk about the two things that I've been doing so far. Backups. Restic is this little Golang backup solution. It is awesome. What was the problem? We were consuming far too much block store with backups. Determining the retention and so forth required, again, application logic, which implemented Ansible. No thanks. We started using Restic, which is just absurdly simple. You create a repo somewhere. And by somewhere, it's file system, it's S3, it's Google Cloud Storage, it's Mini IO, it is set, it is choose. You define the source of the backup. You define exclusions. By the way, whose bright idea was it to have cache in the parent tree of a Drupal project? Oh, God. Yeah, okay. We worked around it. And the first time you run it against a project, it backs everything up, minus the exclusions, of course. And then it backs up the differences only. And this is magic, because it also gives us point-in-time recovery. You get a snapshot each time you get a backup. You can restore it. You can restore part of it, pass within it. You can mount the snapshot as a fused file system. You can do all sorts of goodness with it. And the state of backups improves very, very, very significantly. And then logging. And we're going to talk about, by the way, Promptail did not have a logo. I think Promptail is actually quite awesome, so I made up a logo for it. And we have Loki and Grafana. Why did we need this? Because you don't want the world plus dog SSHing into your servers to be able to tail-f your logs. That's dumb, as it is offering SCP access to your logs and so forth. So this was a moment of reflection, because I am running in production a piece of software named after the god of mischief. I mean, seriously? Okay. But, yeah, we did that. Pronto is an agent. It lives on the nodes. It scrapes the logs in real time, and it sends them to Loki. Loki is a log database, and it's got this format that plays very, very well with object stores. So we can actually do away with expensive and cumbersome block store for our logs and have everything backed up in, stored in this case, GCS. Big advantage, it has an API, it has a command line utility, and it has Grafana. Grafana is the front end. You mostly see it in metrics with Prometheus and so forth, but it does Loki as well. And it gives you embeddable dashboards, which you can OAuth and give your clients, give your operations staff, give, etc. And then you can make a logging controller which talks to Loki and say, hey, give me this type of log for this period. Off you pop into S3, give assigned URL to your customer, you're off to the races. One interesting side effect of this was the realization that log files are kind of a legacy construct by now. It's a stream. Let's treat it like one. And growth continues, fortunately. Everything breaks at a scale. The fact that something that you built for, half or a tenth of the number of environments you're running is now breaking, that doesn't mean you made a mistake. In fact, you did the right thing at the right time. And now it's time to look at it again. Fine. Abstractions are kind of ruthless. If you choose the wrong abstraction for something, as you scale up, your error will become very, very, very obvious because suddenly you're at entirely different levels of what you're trying to do, and you're not a happy camper anymore. It's an interesting process. You scale, you struggle, you solve your struggle, and you scale again. Keep refactoring, by the way, because you keep learning. So if you're not learning, what the hell are you doing anyway? So refactoring is actually a good thing. It's consolidating the value that you have delivered. It's making it sustainable. It's making it future-proof. And like I said, it's iterative. You go from SSH to the very beginning, to shell scripts, to Puppet, to Drupal, Docker, RabbitMQ, Celery, Kubernetes. So it is very important to keep thinking about your abstractions, to keep thinking about your vocabulary, to keep articulating what it is that you're doing for your customers. So we've got vocabulary, grammar, sentences. Maybe this rings a bell. It sounds vaguely familiar, doesn't it? As a, I want to, so that. This type of construct is abused in agile practices everywhere. It's like, for the love of God, cut it out. But at the same time, it's not nonsense. It's just taken too far. In behavior-driven design as well, like BHAT, so forth, you are writing sentences that are then parsed and executed So your abstraction is the test, the scenario, and then you go off with the plumbing to do things. And in domain-driven design, if anyone here familiar with domain-driven design, Ricardo, I expected you. Anyone else? Okay. Eric Evans, Domain-Driven Design. Awesome book. One of the first steps in this approach is to arrive at a ubiquitous language. Ubiquitous, ever present, everywhere. Why is this important? You know, I was a consultant for many years, and my personal record was getting to a company and arriving at 7 different mutually incompatible ideas of what an invoice was. So, if you can screw up something truly that fundamental, nothing is safe. Do not assume that things make sense, because you'll talk to someone and it'll make sense. You'll talk to someone else and it'll make sense, but two people come in, no, it does not make sense. And the Tao of project management is very frequently to arrive at a consensual definition of things that really should be consensual from the start, but surprise, not really. Kill me now. So there's this one simple trick that product managers hate. If your sentences sound like something that your customers would say, if it's something that help desk hears, if it's something that product managers hear, account managers, etc., that is the right level to write a platform, because it reflects the value. When you start articulating something that doesn't sound like something that a customer would say, odds are you're writing plumbing. You're writing things that your platform will use as a driver, as a kernel level thing, but you're no longer writing platform user land. You are writing what it uses under the hood. This separation is crucial for long-term sustainability. It's like decoupling and alignment. Good abstractions allow you to evolve your value proposition. Bad abstractions will lock you in to a level of thinking that breaks at the next scale point or the one after that. It will anyway. But the more you sweat this stuff, the less you bleed once you're at the next scale point. Let's talk about Kubernetes. And let's talk about nouns. All of the nouns that we saw previously, they're very good candidates for custom resource definitions. And you interact with the Kubernetes API to do the create, read, update, delete. Fine. It's almost like the guys who designed Kubernetes were trying to build a platform or something. Weird, eh? But the verbs, the API, as it is, it does CRUD. That what we do, a platform, is far more than CRUD. It'll do CRUD, but that's just an aspect of it, and actually a rather small one. So perhaps we can learn from our past experience. At dropsolid, we abuse Ansible to do all sorts of things. So, hey, what does this look like? Maybe we do need an actual programming language. Maybe we do need something more than declarative, something stateful, who knows, to run our platform. So this is, let's clone an environment. And with two modalities, development and production. Not shown, staging, data quality, stress, etc. There are many types of environment, but this is just to highlight the kind of decisions that you have to make regarding your custom resource definitions. So if A is a production environment and you are running, cloning it to development, you have to anonymize the data because the privacy requirements of production and development are different. You have to put a mail trap on it. You have to reset credentials. You have to do all sorts of things. And eventually, you launch the bloody thing. Yay, party. Same thing from dev to dev. That's actually simple. All you need to do is reconfigure a couple of services and a couple of Nginx proxies or Envoy or whatever, and you're off to the races. In the opposite direction, you have a dev project, you want to kick it to production, you have to truncate the data, request new credentials, deploy, unless, again, not shown because there's only so much slide space. It's a new version of an existing production environment, at which time you have to reuse existing data and credentials and so forth. But the point is, no matter what the details are, this is not something that you can just do declaratively without being mindful of decisions, state, a whole lot of things. Kubernetes gives us operators. They're kind of good. In a way, they look at themselves, they are introspective, and they observe what's going on. You tell it, I want reality to look like this. They diff between existing state and future state, and they act to bring those into alignment. They encapsulate operational knowledge. And that's the big part. That's the golden goose right there. It's make your operational knowledge, your frequently implicit, unknown, known, the lore of your platform, if you will, made it explicit, deterministic, reliable, etc. You can do it with like Python, Helm, Java, the operator framework, whatever, and unavoidably Ansible. But yeah, okay. It was just poor ducky. It's been so abused. Or maybe you can just skip over the entire Kubernetes silliness and go full serverless, because what is the virtue of a Kubernetes cluster once you have your language to implement your customers' dreams and make them a reality? It's just plumbing. And what you choose there, it won't matter as long as you're speaking the right language and you see the ducky is happy and for once not being abused with hammers. And yeah, questions, please.
How do you do the testing of the plumbing? That's the interesting point for me.
I'm sorry?
How do you do the testing of the plumbing? You are doing domain-driven design, but you are actually switching implementations, so you have to do some testing on your infrastructure.
Yes, you do.
How?
And the good news is that if your platform is good, if it speaks the right language of abstraction, you can test your new version of the platform in your platform. That is part of its semantics.
Yeah, but you need extra tooling that should be also tested.
Exactly. Inception. It's recursive platforming. And look, it's good drugs. I approve.
More questions? Okay, I have a question, of course.
Go for it, mate.
So in your journey here, which is quite interesting, what did you find that was more difficult to achieve in terms of scale? Because the topic of the session is Drupal at scale, right?
Yep.
And what was the most difficult Drupal thing to scale that you find in your journey here?
It is updates. It's the hammering the Drupal API with state updates. You start lagging, you get deadlocks. Drupal is not an application platform. And this became very obvious once we already had quite a bit of investment in it. So, we defended, we got the queues in place, we got some actually very smart queuing, but now you shifted your constraint around. You shifted it to something that is very robust, very easy to inspect, very easy to recover. It has a good interim state store. It's got good semantics. So it is better than screwing up on the application side. But if we had the hindsight to start this all over again, the stateful part of the platform would not live in Drupal.
Okay, so not, sorry, I need to ask this. So you mentioned operators. For me, I see operators as like they're not people, like the operations team.
Well, yeah.
Now they are machines, so it's automated operation.
It's a DevOps kind of box.
So what you just mentioned, is that using the operations or the Kubernetes workflows?
It doesn't matter.
Okay.
But I mean, specifically, this problem we had with Drupal was before our Kubernetes journey, so not really applicable as such. And in a way, our Kubernetes journey was propelled by needing to fix the stuff that we did that was not scaling.
Thanks.
You're very welcome.
Any other questions? No? Okay, thank you, Manuel.
Okay, cheers, guys.